Hi, statistics student. This video is for chapter 8, 8.1, part 2, confidence interval for mean. In the first video, I was talking about example 2 and I didn't finish. We were given a sample mean X bar, some kind of measurement, and this sample has 40 data. The sample's mean is 76, but population standard deviation is 6.5. Sometimes you would have sample standard deviation. We don't really need that because in our calculation of error, we only need sigma over square root n, right? But we need to know how many tick mark it is from the middle, from the mean. So we do inverse normal using 90% as the middle. 90% as something that is likely to occur by chance. So I do inverse normal 0.9 and I click in between. So 1.645. Now, other books or other video would use above and then do an error or an area of 0.05 because if you think about this, okay, recalculate. So if you have 5% tail or if you have 90% in the middle, then you would have 10% total at the two tail. So one tail is 0.5, which is above. So you can see that it's 1.645, the same number. But I usually just do the sea level 0.9 so that you can see that 0.90, you can see that it's the same 1.645. So whatever that works for you. 1.645 is the positive critical value. Okay, so I write z equal to 1.645. 2 or 3 decimal places is sufficient. Find the error bound. So we say the error bound is z alpha over 2 times sigma over square root n because this is the standard error. So that's 1.645 times sigma is 6.5. Right? So circle those over square root n. N is here and you go to 40. You just put in the calculator. 1.645 times 6.5 divided by square root of 40. 1.69. Okay, find the confidence interval. So we say 1.69 is x bar, what your x bar is, plus and minus e, right? So that means in plus and minus notation, x bar is 76. So 76 plus and minus 1.69. So if I want to do inequality notation, I would say 76 minus 1.69, 74.31, and then I got 76 plus 1.39. That one is easier, 77.69. And that is the interval. That means I don't know where my mu is, but the fact that my x bar is 76 indicate that my mu could be as low as 74.31 and as high as 77.69. So let's look at how we can actually accurately interpret it a little later. But of course, we don't want to do this hand calculation all the time. There is a program in statistics that can do it for us. And also, if I have data, haven't summarized, I just have the data itself. We can also use statistics, or we can use or LibreText calculator. So when you have data, you can continue to use statistics or LibreText data. When do you use it? You would use it if the data is in comma list form. And if data is in like a table form, or you have X bar, then you use statistics. That statistics can handle anything. You can use summary statistics as well as data. Okay, but when data is not in like the vertical table form, but it's in comma list, then you use LibreText. So let's go over that a little bit. So I have statistics here. So what you do is you go to analysis, confidence interval. You want to do mean one sample, analysis, confidence interval, mean one sample. You put down your confidence level. So that's 2 tabs, summary statistic tab and data tab. So in data, you don't enter anything. You just tell what is confidence, what is the confidence level in decimal form, and then you put your data here. You cut and paste your data here. If you have summary statistic, meaning you have sample mean, you have sample standard deviation, you must know your population standard deviation though, right? In 8.1, because we are just doing z to calculate sigma over square root n. So that's how you do it. Use summary statistic or data. Okay, so let's go back to our notes. And what about LibreText? I'll do an example when I am doing an example when data occurs. So here, this is a picture on why we would do inverse normal. So it talks about sea level is in the middle, the two tails are alpha. So half of the tail will be alpha over 2. So this is called the critical level. So you use inverse normal, calculate the right tail or sea level in between. Okay. Interpret sea level. So if you find the interpret a confidence interval, not a sea level. So you would say we are confident that the true population mean for whatever population is between that number and that number. Another interpretation is I construct one confidence interval. If I draw more sample and I construct more confidence interval, that many percent, if it's 90% level, then is that percentage will contain true population means. Okay. The next things after you construct a confidence interval is what can you use it for? So because we don't know what mu is actually supposed to be, we know that it is in a range, it's an interval, right? Having a low number and a high number, but population mean is just one number. It could be any of this number. So any value in the confidence interval can be mu. We just don't know. We only have one sample, right? If the whole interval is greater than a number, so for example, this is 5 and this is 7, all of them are greater than 1, then you say my mu must be greater than 1 because it's outside. If the whole interval is less than a number, so for example, this is 4 and this is 7 and 10 is here. So any mu that can happen would be lower than 10, right? Then we can conclude mu is less than that number. So when two confidence intervals overlap, we cannot conclude one is higher. So sometimes we construct two confidence intervals, maybe one for mean of something and then the other is mean of another things, another populations. So they may overlap. If they overlap, then they may be equal. So you cannot conclude one is higher than the other. And in chapter, okay, this is 8, 9, 10. In chapter 10, we'll talk about how to compare two confidence intervals officially. Okay, let's do some real example. Suppose, so it's not like a generic example. Suppose scores on a standardized exam are normally distributed. So these original data are normally distributed. The population standard deviation is 35. 14 score, so although it is 14 score is lower than 30, but I know the original data is greater than 30, so this is fine. X bar is still normal. Sample mean is 137.3, so it is a lot of numbers. So this one is sample mean, so this must be X bar, right? Sample, the population standard deviation, this is sigma. 14 score, this is sample size. And a sample standard deviation of 37.2. I don't need this because I only need sigma. So use it to estimate the population mean of the standardized test at 98%. So we want to know all the test score. So the first step we usually does was to consolidate all this information. What is sea level? Okay, it's 0.98 because we want to do 98% confidence level. 0.98. What is n? N is 14. What is x bar? It's 137.3. And what is sigma? Sigma is 35. So these are test score. So now we are ready to do the intervals by plugging in those numbers. I write it down: 0.98, 14, 137.3, and 35. So I'm going to go to stat this. Remember, so I have it. Maybe I'll do it again. Confidence interval mean one sample, and I have statistics, right? So 0.98 for the sea level. Sample size is 14, very small sample. Mean was 137.3. And I don't need this one. I blank it actually. I delete this is nothing. I want population standard deviation is 35. So if you enter anything here, they're not going to do uh, take it. So you don't have to enter it, but you could if you want to. Could evaluate. See how this is much faster. Your E is 21.76 if I round two places, and the lower limit is 115.54. I'm going to write it down, 115.54, and then the upper is 159.06. So they calculate everything for you. You don't have to worry. So I think I have it over here, 115.53, 159.06. Yeah, 21.76. So this is the output. Okay. Interpret the meaning of it. So we can say we are 98%, because this is 98% confidence, that the true population mean standard score, this is the true, is a population mean mu is between 115 to 159. So I don't know what the real means for everyone is, although my X bar is what was it? 137, but the real population mean could be between these two numbers. C, it should be C. At a 98% At a 98% interval, what is the significant level and the critical value? So you notice that when they output it, there is no Z, right? They give you E, they calculate it for you, but they hide the Z. So we want to learn how to do it. So this is 98% and the critical value is Z. So we use the inverse calculator again. I have the inverse normal calculator. The middle area is 0.98 because I'm doing 98%, so I do in between and recalculate. So it's 2.326. 2.326. So that's how you do it. What is the margin of error? Margin of error is in the output 21.76. In the output 1.76. You don't have to calculate, but I think if you do this and multiply sigma over square root n, it should work. Last one. The previous studies say that the mean score for everyone was 144. Is this mean below 144? Well, our mean can be from 115 to 159. So if I draw a number line, the new mean can be from 115. I should do more. 53. 115.53 to 159.06. 159.06. So any of this number could be mu. Are all of this below 144? No, 144 is here. This one is below, but some of them is not. So you cannot be sure. You cannot be 98% confidence. So we say no, because 144 is not outside, it's inside the interval. So no, because some value like 145 and 159, this could be mean also, right? Is not below 144. Only some of them are. So you say no. We cannot conclude because it could be greater. Okay, so I'm going to do one more example in the next video. So all in all, what you do is you have your sample, you write down the information that you need to run the statis, which is sea level and X bar and sigma. And then you put it in and they will calculate it. After you calculate it, you interpret it, and you also look at what is possible. What can you interpret from it? So how much can mu be? Is it greater than a number or less than a number? Something like that. So we'll do the second example using actual data instead of finding X bar in the next video.